Hey guys, let's take a look at how Geogebra can help bring systems of equation type problems um, to life, so to speak, and see the solution. Therefore, the algebra that we end up going through can help make more sense to students that actually have an understanding of what the solution to a system of equations is, and therefore seeing the patterns in the algebraic and symbolic form in our manipulation to actually solve without seeing a picture. But I think it's crucial for students to see, uh, like for systems of equations, to see what the solutions are first before we do the algebra stuff. So here's a NAEP item that I found. It's just a system of equations. Take two equations in standard form. What is the value of x for the solution? So then we would go through some elimination process and find out what x is. But if we use GeoGebra to show you very simply how we can take each equation, even though it's in standard form, this is what's nice about GeoGebra versus the graphing calculators, where I believe you have to have your equation in slope-intercept form or know some way around that. But GeoGebra is nice because we can actually just input in our input bar each standard equation. So this first one is x plus 2y equals 1. So I'm going to go to GeoGebra. Since I'm graphing, I want to see my axes and my grid. So I'm just going to hit these little toggle buttons here and turn them on. If you don't see yours, your options here, these toggle buttons, then this little arrow next to graphics isn't collapsed or opened up, I mean. So now, if it's pointing to the right, pointing towards the word graphics, our menu isn't open, so drop down. So just hit that arrow and you can see your axes and grid options. So now I'm just going to click down here in the input bar, and we're going to put in that first equation, which was x plus 2y equals 1, and hit enter. And there's our first line. And so then we're just going to input the second equation, 2x minus y equals 7. 2x minus y equals 7. Hit enter. There's our second equation, and we can see our solution is going to be at 3, negative 1. And what we can do too is actually put the point to show that it's xy coordinates at that point, or the input output, depending on your conversation, is going to be, if x is 3 and y is negative 1, then that's going to be a solution to this first equation, and also a solution to the second equation. So just graphing, we can see where both lines are equal, therefore the x and y pair satisfies both equations. This is also a nice trick to use this system when, even if we don't have linear systems. Let's say that we have a quadratic equation and we want to teach it as solving a system of equations. Let's say that we had a quadratic expression equal to, say, a linear expression. So just to kind of take this idea and extend it, let's say that we had, and I'm just going to make this up, 2x squared minus 4x minus 5. And that's going to equal some linear, maybe we'll call it x plus 2. And we want to solve this, right? So we can go through our whole algebraic way of getting all of our terms on the left side, then we got a quadratic formula and we can solve. But to get a visual of what we're doing, this is just its own number pattern. It's a quadratic pattern, therefore it has a parabolic form in its graph. And this is just linear. So what we can do is take the same idea here. I'm going to go ahead and just delete these two lines. And now down in my input, I'm just going to input each expression. So the left side of our equation is just 2x squared minus 4x minus 5. And when I hit enter, there's our quadratic. And we want to find out when that, the x and y coordinates that are the same in this linear pattern, x plus 2. So I'm going to graph that as well. So we could see that our quadratic number pattern with these x and y pairs, right? And we could even put a point on here and check it out. Oops. Okay, so if I move A, there's the coordinate points, so some input output, and I can get kind of close if I wanted to this intersection and actually probably get on it. Okay, to kind of see that if we put in that x and y negative 1 and 1, if we let x be negative 1, we should get a value out for 1 for this expression, and should be the same for this, right? Negative 1 plus 2 is 1. So we can see that solution, and if we take, let's just do this real quick. Negative 1 squared is 1. 1 times 2 is 2. Negative 4 times negative 1 is a positive 4, so we have 2 plus 4 is 6. 6 minus 5, hey, we get out of 1 also. And when we come over here and look at this solution that hopefully we can get on, we can see, and without even messing around, I like having a moving point so we can see xy pairs, and these are the two magic xy combinations that satisfy both curves. But you can see that's kind of a pain. I like to use the intersect two objects, or just place a new point on the intersection. But if you use the intersect tool, you can just click on your parabola, click on your line, and it gives us both. And it tells us the input and the output values at those solutions. So GeoGebra is awesome when it comes to solving systems, and it's a great confirmation. It's a great way to solve equations just visually. And then when we get to solving the algebraically, we can make some connections to the solutions that way as well, and students won't be so lost when we go through the procedure side of solving systems. So I hope that helped you guys, and good luck with that.